magma. The types of igneous rock already we have discussed in the last lecture. There are three main types, that is the igneous rock, sediment rock and metamorphic rock. Out of these, in igneous rock, again there are three types, that is the extrusive igneous rock. It is also called as a volcanic igneous rock. Second one is the intrusive igneous rock. It is also called as a plutonic igneous rock. And third one is the intermediate igneous rock. Intermediate. It is also called as a hypabyssal igneous rock. These three rocks are formed at different temperature pressure condition and at different locality of the earth crust. Firstly, igneous volcanic rock is formed on the earth's surface, as well as plutonic rock is formed at the below the earth surface at great depth, while the hypabyssal rock is formed at the near the earth surface. We have already seen in the last lecture this diagram. This is the magma chamber, means magma is originate below the earth surface at 50 kilometer to 250 kilometer. Now this is the magma chamber, and from this magma material comes on the earth surface. It also inject within the earth crust, and this also inject near the earth surface. On these three locations, extrusive rock is formed on the earth surface, intrusive rock is formed below the earth surface. These are two types. This is the intrusive igneous rock, that is the plutonic, which formed below the earth surface at great depth, while other one is the hypabyssal rock, which are formed near the earth surface. These three rocks having the different temperature and pressure condition. Depend upon these conditions, extrusive rock having the very fine grains of the crystals, while this material, that is the hypabyssal rock, having the medium sized grains of crystals, while this material, that is the intrusive or plutonic igneous rock, having the very large crystals because of the cooling condition of the magmatic material. Now here cooling is very slow, relatively cooling is slightly faster, and here on the earth surface cooling is very rapid. Because of rapid cooling, that magmatic material cools very rapid and form the very fine grains, while here medium sized grains are formed and here very large grains are formed. Example of this extrusive rock is the basalt. Basalt is in our area, we can see everywhere basaltic rock. Now this is the dolerite example is the dolerite, while this is the granite. All these rocks are seen by every student in our area. Granite is not seen in our area, but mostly it is used as a building stone. Dolerite is also available in our laboratory. You can see when our practical is seen. These three types of rocks we have seen in the last lecture as well as today. Now next point is the composition of magma or composition of igneous rock. Look at this composition. Depend upon the cooling condition, three types of composition is also there. First one is the felsic. It is also called as a sialic magma or sialic rock. Felsic or sialic is nothing but contains more than 65% of silica. Depend upon the silica percent, it is also a felsic or sialic rock. Next one is the mafic rock. Mafic, its silica percentage is less than 45%. Less than 45%. While the intermediate magma its percentage in between 65 to 45. And also along with felsic rock, silica with more amount of aluminium and potassium, while in the mafic rock silica percent is less but more amount of ferrous, that is the Fe and Mg is more amount in the mafic rock. Depend upon this composition of magma, igneous rock is also divided into three compositions, that is the acidic igneous rock, basic igneous rock and intermediate igneous rock. In acidic igneous rock, silica percent is more than 65%, while in basic igneous rock, silica percent is less than 45%, and in intermediate in between 45% to 65%. But if the silica percent is less than 45, it is also called as a ultra basic igneous rock. Just like dunite is the example of ultra basic is the dunite, intermediate is the dolerite, basic is the gabbro basalt, while acidic has the rhyolite and granite. We have seen in the last lecture. Now next point is the origin of magma. In origin of magma, already we have seen in the last year there are lithospheric plates, that is the earth crust. In earth crust there are several lithospheric plates are there. There are 7 major plates while 13 minor plates are there. All the plates are continuously in motion. When these plates are in motion, they are collide with each other or they may migrate from one to another way. Now look at this. This is the one plate while this is the other plate. These plates are maybe running from this way, that is the diverse way, or this may be converse way, means both the plates are converge each other. They are plates motion in towards each other. At that time one plate is goes down below the earth surface. When that plate having the density more, that plate is goes to the down of another plate. Look at this. In the next step what happened, this is the first step. In the next step, this plate, that is the plate A and plate B, plate A having the higher density, that plate goes down to the plate B. This is the plate B while this is the plate A. This plate is goes down in the asthenosphere. Below this layer, this is the asthenosphere. Its thickness is up to 75 km. We have already seen in the last year. Now this is the asthenosphere, means lithosphere. This is the lithosphere, and below this asthenosphere, after this mesosphere. We have already seen in the last lecture. In this asthenosphere, this crystal rock or solid rock is not stable. That material melt when temperature and pressure rises at that location. This material is melt and it forms the magma. This is the magma. This magma when comes again on the earth surface, as well as it inject between the layer of the earth. In this way new rock is formed and origin of magma is here. Now today's lecture, this is a sufficient material.